Life hacks. Technology, business, multimedia, wellness and health, events, reviews, and more. Life hacks. This is Mary Collins from Life Hacks Media, and I have the pleasure to have Rob Knight online with us today. Hi, Rob. How are you?
Hi, I'm great. Thanks. How are you?
I am thrilled to have you on the show today because you are presenting today robots and science fiction. So I'm super happy to have you, and I'm just going to tell our audience a little bit more about you. So Robert Knight is the founder and robot hardware designer and team leader of AI Integrated Hardware. He's an expert in rapid robot development, and he is one of the world's first his robots are one of the first commercially displayed robots in the world and most anatomically accurate to humanoid robots. So anyway, his robots have featured as centerpieces in major exhibitions. For instance, Robots London Science Museum, now touring worldwide, and is on the front cover of an international design magazines. And Robert is also part of Team Mortis, a team which competed in series 1 through 4 of Robot Wars. So
that was a long time ago.
It was so amazing. Consisting of members from Cambridge and Nottingham, they had entered the main competition in the series with Mortis and is still probably is one of the most technologically advanced robots to complete in the early series. His company offers tutorials, support, and customization of all their designs, spanning from the tiniest details of mechanical assembly and software installation to the grand overview of how to integrate robot systems within society. So with that, Rob, standing behind you, for all the people who are just listening, standing behind Rob right now is the cutest Wall-E / I don't know, like E.T. robot. Plus, there's actually 3 of them. One has buggy red eyes, and then there's one that looks like he's 6 feet tall. And you can see what looks like their vessels, their blood vessels, but they're electrical vessels running through their system, through their hands, and they have like hands and everything. It's like amazing. So, for anyone who wants to see the video, they can go on to lifehacks.com. That's with the K and an X. So just describe to us, Rob, who do we have? Who are your 3 compadres behind you today?
So these are in fact 3 generations of robots which attempt to copy the human anatomy. And I started these when I was a student in Essex, almost 20 years ago now. And the word that was coined by my professor was anthropomimetic, because it's got a Latin and a Greek root, which he thought would annoy people. So it's the copying of the anthro and the mimetic, so copying of human systems. To the original project, in fact, was to try and investigate consciousness. And the theory was, if you're going to create an artificial consciousness and it needs to be embedded, then it needs to have a body which is human-like. So the commission was to try and make a robot which is as human-like as possible. So I copied all of the joint structures. It's got ball and socket in the shoulder. I copied all the muscle layouts, and it has elastic tendon-driven drives. So instead of being a stiff industrial robot, it's kind of bouncy. The project itself didn't produce any great insight into consciousness, but the robots had a strong effect on people. They were just kind of fascinating to look at, and we realized that because they're built in a similar way, they move in a similar way, and humans are hardwired to recognize other humans. So this kind of fascination just led us onto other things. So this one down here, in fact, the red things are not eyes; those are the speakers. They only have a single eye.
Okay. I see it. Okay. So
this is the eyeball here.
Wow. The eyeball, guys, looks like the nose, like a big bulbous nose, but that's apparently the eye or the camera.
It only has one.
Yeah, I see that. But now that you've lifted it up, but when it's kind of tilted forward, the speakers on either side look like the eyes and the camera looks like the nose. And then there's a little red thing at the bottom that looks like the mouth. What is the little red thing?
Oh, these are just the motors of the cheek. So it doesn't have an explicit face. It has implied features. If you notice, this piece here, which joins the motors, is curved upward like a smile.
Right.
So it's the same trick you use in car design. You make a car look friendly or unfriendly by these kind of subtle features, because humans love to project anthropomorphize objects. So to avoid having to make a really good face, which is extremely difficult, I made a very crude approximation and just put in little features, which are a bit like a smiling mouth, which are a bit like ears. But the one eye thing came from our partners, I think, at Bristol University. And what they told us is that although humans have two eyes, you don't need two eyes to generate stereo vision. And in fact, 10% of people can never achieve stereo fusion.
Okay.
You remember there was that craze a few years back, they're called autostereograms, and there's a hidden 3D picture inside this kind of overlapping pattern.
Yes.
When you look at it a certain way, they suddenly pop out.
Right.
So 10% of people can never see those images. Their brain just hasn't achieved that level of stereo fusion.
Wow.
And this came as a big surprise to all of us. So it turns out the way the brain interprets the information, that is hardwired to be three-dimensional. And there's an experiment called the Shepherd's table illusion, which is a parallelogram shape, and viewed one way and viewed the other way, just by drawing table legs underneath it, you're convinced that the two shapes are different sizes. But you can actually lay one on top of the other. And if you look it up, Shepherd's table illusion, and that's quite convincing, because
Rob will have, I know you have lots of this really cool, fun stuff that sounds almost like mathematics, and so it's scaring me. But what got you into robotics specifically?
Into robotics, crikey. I honestly don't know. I've been asked this before. I've never had a decent answer. I've always built robots for as long as I can remember. Started out in sellotape and cardboard and paper, and then went through materials at school, and then went to university and kept building them, and then did TV competitions. I've just always built them, and I assume it was something to do with Transformers, and then later on Terminator. But that's the best I've got. I've just always built them.
But so you, I remember, well, I think probably we'll talk about it later on, but you had said to me in the past about the people don't realize that building robots is not necessarily, it's an engineering, but there's engineering and there's other aspects of robot building and the IT world. So do you want to give us some of your top hacks of what one needs, the skill sets to begin building a robot?
Oh, okay, sure. I always consider there are three main areas: mechanics, electronics, and computing. And if you don't have all of those three areas working to a reasonable degree, then you won't produce a robot. A robot has to have some intelligence, is maybe too strong a word, but it has to have some aspect of reacting to its environment. It's kind of what differentiates it. So some people claim that a thermostat is intelligent because it can sense temperature and it can change the way a machine functions. And I'm not sure I agree with that. I think that's too simple a machine to be really demonstrating intelligence. But yeah, the crux of it is that all of those elements have to come together. And then if you put it into what's called an embodied system, and then it's a situated embodied system, then you create a standalone machine, which should at some point start interacting intelligently with its environment. And then you're really getting towards a useful definition of a robot.
Okay. Why work harder when you can work smarter and live better? Life hacks.
So for somebody to get interested in the robotics world, what kind of courses do they take? Like if they were to pursue this at a university level or a college level, or technical level, what would they have to be getting into?
At that level, I think it probably actually splits into two. Mechanics and electronics are frequently covered in a course called mechatronics. And that will allow you to build machines which have electrical systems, which is pretty much all machines these days. They would have certainly, I'd have thought, some low-level microprocessing, and that will take you up to a certain point. Kind of coming almost from the opposite direction from from mathematics and pure computer science, you then now start to have the development of AI systems and how those can be applied. And that, in recent years, has become much more about programming. The kind of fundamental questions of how you do AI, whilst it's still ongoing, there are now lots and lots of solutions, and how you code that and apply that and prepare your data and to produce a useful AI system, that's a much more pragmatic question now. So realistically, doing both, I think, is doing both to a very high standard, I suspect, is probably not practical. There's just too much to know and it's too difficult. I'm a little unusual in that I'm much stronger on the mechanical side. And my electronics, frankly, is not great, but I know enough to get systems working. So I really specialize on the design end and producing these unusual mechanical systems, because I always hoped that at some point the computational systems would get much easier to use in the way that computational systems do. I mean, right at the beginning, if you wanted to do anything on a computer, it was very, very difficult. And now you can do incredibly complex things with no real understanding at all of what's going on underneath. And that's certainly true now of AI. If you want to do any kind of image recognition, you're very unlikely to write any of the code which does the hard bits. You're going to call people's libraries in, you're going to tell it where to look, and you're going to tell it what to do, and you're going to adjust your settings, and you may even get an AI to adjust your settings. So you now have AIs controlling AIs to produce better choices and more possibilities. But all of that is pulling in code which was written by hundreds of thousands of hours of coding by other people, and you don't have to know how any of it works. You need to know how to drive it.
Okay.
So as that side becomes more user-friendly, it'd be like if you want to write a website now, you don't have to understand any of the deeper stuff. You can do it in WordPress. And we're almost at that level with AI systems, where you're going to be able to start to, without any real depth of knowledge, get them to do very impressive stuff.
Okay, so what do for the future of for people who are interested in the investment side, do you see that the advancements are going to go towards more the mechanical at this point? Is that where there's more of a need? Because obviously there are people writing programs and apps, et cetera, but is there more of a need in the mechanical? What's missing in the robotics world currently?
I'm pretty sure we've now gone past the stage where nothing fundamental is now missing. So all of the individual technical items that you need to create a complete system exist. Whether or not they're accessible, whether or not they're easy to use, whether or not they're all compatible is the stage we're at. So in fact, with the ARM that I'm presently working on with NVIDIA, we're at the stage where we're trying to transfer the mechanical design from SolidWorks, which is a computer-aided design, a CAD package for mechanics, into actually via another third-party modeler, and then into their modeling program, which will then allow you to apply all the AI to that. And these two systems, although they look similar, they generate their models in fundamentally different ways. So making all of that compatible and working out all the bugs, and when you do an importation, it loses some bits, and making all of that work, that's kind of the stage we're at now.
Okay. So for all the career change people, this is where, I guess, or people that are working towards careers on the university level, like you said, getting a course that handles a bit of mechanics, mathematics, physics, computing is a good start. What about for the younger generation? Like for people who are thinking, what would be a good idea for present to kind of get kids into the future of what robotics might be? Are there any sort of sets or anything that you recommend that might be a good start?
Certainly for kids. In fact, even at university, we were still using it. The Lego Mindstorms kit allows you to do a lot of simple experiments very quickly, because you can build the mechanics obviously very easily in Lego. And they include, they call it a brick, but it's a computer which was developed with the MIT lab. And there's a graphics interface, which is what it ships with. And then it's been reverse engineered with a language called NQC, not quite C, which is like C programming, but not all of the features. So you can very easily hack it, which is what we did, and then bring it up to a more advanced level.
Ooh, I like that. We like that on Life Hacks, quick and easy ways to get, not necessarily easy, but definitely better ways to get to the point of what someone wants so that their life could be made much better. Perfect.
Life Hacks. Lifehacks.com. That's with a K and an X on Radio X.
We're back with Rob Knight, our present day robots versus science fiction, and he is going to tell us a bit more about what he's currently working on. Hi, Rob. What are you currently working on?
Okay, so this is our first attempt to get an AI-powered robot into the market, shall we say. This is an open source project, which means you can download all of the STL files to print your own, or you can buy one ready printed, which is this kind of version. Now, this is the first one, so it's got a few repairs on it. You can see the bits in different color. And it's in programming, you have something called a hello world program, which is the first bit of code you write, which proves that everything works. And typically the words hello world will flash up in a terminal or on a screen somewhere. So with this one, this is a hello world which combines the mechanics of building the robot hand. And in this base, there is a small computer, NVIDIA Jetson Nano, And onto that, you have to program, follow some instructions, get an AI program working, which can recognize hand gestures. There's a camera normally built in the center of this hand. And when you hold your hand up in front of it and you move your fingers, it copies you.
Cool. Is this something for like an age group, or is it quite an expensive project? Is it something a company can buy, or is it something a school can buy? What are the?
I think if you print it yourself, if you already have a printer, then the computer and all the motors and everything else should work out no more than about €400. I think it might be possible to do for a bit less than that.
Cool.
And if you buy one professionally finished to get a very nice quality hand, then it's going to cost you about 600. So our aim was really more developers, people that want to know more about how they can apply their computing skills into robotics. But certainly I think higher education is possible, definitely universities, and even I think a high school could certainly take it on as a project, a group project, which maybe lasts for a term. Then it will teach you a lot about, if you do your own printing, it'll teach you about printing, it'll teach you about assembly, it'll teach you about different materials, it'll teach you about the design, it'll teach you about how you put all of that together, it'll teach you about how you got the servers running, and then finally it'll teach you about installing a computer and getting the first bit of AI running. And then finally at some point you will hold your hand in front of it, and like a miracle, the hand will copy you. And that's using some very sophisticated AI models, and you don't have to know at all how they work. You just need to know how to install them, how to call them, and where to load your images, and it means everything is working. And
that is amazing. And for people who are interested, they can just go on to therobotstudio.com website, correct?
So that's my website, and the website for the hand is robotnanohand.com. Nano hand, because it's a robot and it's using a nano computer and it's a hand, all one word, robotnanohand.com.
And of course it'll be on lifehacks.com. That's with a K.
Thank you.
So, okay, well, now that you've mentioned, and I think also for team building, because when you were talking about earlier the aspects of needing a bit of like IT, engineering, and mechanics, this is an opportunity, I guess, for the robot industry for people to work together, whether it's a family, whether it's a school, whether it's university students, to kind of bring different departments together and get them to work, or corporations even, to work on the future by using whatever resources they have available to
I
get
suspect
together.
it's one of the reasons that robotics has taken so long to get to this level.
Yeah.
Is that it is interdisciplinary. And disciplines, almost by definition, don't particularly like to mix with other disciplines. But you have to cross those boundaries. If you can't cross over those boundaries, then you really can't create. And the system emerges. It's very much greater than the sum of its parts. It's a pile of motors. It's a pile of electronics. It's a bunch of code. And when you stick them all together, it has this effect. And technically, it is more than the sum of its parts. But certainly how it affects people is a lot more than the sum of its parts and people's expectations. And if anything, going back to education, that's the next phase, which is going to come in very strongly now. Once the technical stuff is done, once it's a known quantity, once it's worked a few times and you've got a pretty good idea of how to call it up, then the real focus is going to be on how we integrate that, how we integrate that socially and culturally. And like the start of the internet, there's going to be this phase of, well, what's the point of it? What does it do? We didn't have it before. Why do we need it now? But once it starts to become commonplace and reliable and a known quantity, and people it will iterate, and it's going to iterate in very, very unpredictable ways, I suspect, in the way that the internet has done strange things you wouldn't have expected. Robotics will do the same. And the way I think about it is that the internet removed the concept of distance from information, and robotics will remove the concept of distance from action.
Okay. And
it's very hard to predict what people are going to do with that. But there's a lot that needs doing at the moment, and I would really hope that it's a serious force for good in the world. But really, I think that there is a lot of potential for that. So it needs to be done responsibly, and how it impacts people needs to be really taken into account right from the start.
Right. No, that's brilliant. I mean, literally, if I was a professor at university, I'd have the law students on board, the medical students on board, the IT students on board, the mechanical students, engineering. It is definitely, people are afraid that robots are going to separate society, just like in RUR. The very first time the word robot was used was by Karel Capek in a stage play that he created. based on 1932, I think it is, or maybe it was before.
It was 23. There's a 2 and a 3 in there, I'm pretty sure, but.
Right. Okay. Well, yeah, it was 19 something. And but I think they were called autonotrons before. And then he was the first time to use the word robot. And
Which
the
is
whole
mechanical slave in Czech. It's mechanical slave.
Right, exactly. And he is Czechoslovakian when it was called that.
Yes.
So it's it's an amazing thing because, of course, there's that fear, just like there's a fear with hypnosis and these things that it's going to tear people apart. It's going to make things worse for people because the robots are going to take over. But in actual fact, what you've just told us, Rob, is that in a way, it could bring society together into a new age of enlightenment, into a new age of industrialism that's positive because people who are struggling in work on their own, like there's too many IT now maybe that are coming into the world, or there's too many one thing and not the other, and people who are being replaced by machines. So if we used our skill sets to work together to create machines that are for the embetterment of mankind, humankind.
You can but hope. There's definitely the potential for that. I mean, it's like any new technology, there's potential either way. And if you look at people's opinions of Facebook at the moment, is social media a good or a bad thing? But this will be an intimate...
It's what you do with it, right?
Well, exactly. It's what you do with it. And actually, it pops up in the Terminator films because the Terminator starts off as a bad guy and ends up as a good guy. It's a technology. It doesn't have its own... doesn't have its own feelings, and the idea that there's going to be a super intelligent AI which is going to condemn humanity, that's just complete fiction. That's where all of the advances we've had in AI are what are called very narrow advances. So the computer which beat the human Go or the human chess champion doesn't even know it's playing a game.
Right. It's just following programs and learning from its programming. So this is it. It's just like, it's just like, as I said.
It's the way that it integrates with society. It's the way that people learn how to control that tool, which is really going to affect the direction it goes in. And also, of course, for money. It's very important that mechanisms are built in, which means that if you contribute data, and data, I suspect, is the key, in fact, because in these examples I was talking about earlier, where you have these programs where you're using all these libraries and you're standing on the shoulders of giants, right? You take hundreds of thousands of hours of effort, and with a single line of code, you make it do something. Despite all of that, you still have to prepare the data. 90% of any project is making the data neat and consistent and well labeled and all the things that the program, because the program doesn't know any better. It will only do as well as what you feed it. So if you wanted to do something well, you have to give it good data. So if you know how to do something and you curate your data set, which allows the robots that you have access to do that task, and you can then sell that data to other people, as long as you get a cut of that knowledge, then far from taking your job from you, you've got a way to monetize your skill. And if every person that has what is, I think, somewhat offensively called low-level skills or low-skill job, because they're not. You need to know how to do stuff. If you can enshrine and encapsulate and capture that, and you're responsible for making sure that it works, then every time some other program somewhere else does whatever it is, grows tomatoes, irons shirts, really cleans a toilet well, whatever it is that you're good at that you can teach it to do, which is considered worthless now, will suddenly have a value. And that, to me, is a really crucial part of the whole thing.
That's interesting. And speaking of which, do you run online workshops as well as consultations for companies?
Not yet. I'm hoping it'll come up once we have a few people who want to know how to build the hand. The hand, in many ways, is also a hello world in the sense that, hello, we're here. This is what we've done. If you like it, come and see the other kind of stuff we're working on. Once we've got a hand and an arm and a visual system and it's hooked into a powerful simulator, which is really very, very near to being quite straightforward to do, then I think you're in a situation where, it'll be worth running classes, and then there'll be a class on how to build it, and then hopefully I'll work with some programmers that can take on the other aspects that I know less about. But that whole cycle now of, we're at that stage where most people don't even know what a website equivalent is. No one knows how to write them yet. So making that comparison between the internet and the robots, we're at that stage where all of a sudden it's just going to be possible, and all these things are going to be going on. And people are going to need to know how to do it. So I think that phase is coming up quite soon.
Okay. Well,
but the demand is not really there yet, frankly, because it's not a complete system. It's still kind of gimmicky, but it's getting there. I really think it's getting there.
Well, that's like you said, and it starts with teamwork and collaboration. That's where it starts. It really will take off once people get out of their little boxes of I'm specifically an engineer, I'm specifically an IT, and they start realizing, listen, I want to just make a better world, so we're going to work together with the engineer, and the IT will work together. And they can start from a young age, people. Rob has mentioned that there is like a Lego system that you can actually do basic learning on. And there's definitely computing packages now for children that they can learn to write programs and such. And we will have more information on lifehacks.com. And of course, we'll have Rob back on the show telling us what exciting advances he has made and to see some of his robots moving around next time. Thank you so much, Rob. It's been an absolute pleasure.
Thanks very much. Nice talking to you.
It's not a problem that I can't fix, because I can do it in the mix.
Lifehacks.com. That's with a K and an X on Radio X.